All right, so let's get started for day 2 here. I did want to cover day 1 a little bit. This is a little different than where I left off with day 1. I sat around and just cleaned it up a little. There was a little frustrating where I couldn't get map to work, and the reason why is because I was flipping these parameters. I had numbers and then int, but map wants the function first and the list second, so I just had to flip that, and that solved the problem. So I was able to do this to clean it up a little bit, so that worked better that way. And then, but map is typically not always considered the most Pythonic thing. So another way you could write this is you could say map of int n for in of in numbers like this. And that's the same thing as a map. It's actually faster than a map in Python. So this is probably more Pythonic and a little bit better. But yeah, you could do that. Yeah, you could also like change this here to put, you could do this. You could do like elf, and then you wouldn't need numbers here. And since you're doing that, you could also, instead of appending sums, you could do the max of this whole thing. So you could do basically the max of this. Let's think. You want to do this. So the max of sum for elf in like that. And there's a one-liner. And then you could do it like that. But then you'd have to do the whole thing all over again, right? So you'd have to do the whole one line all over again for part 2. And you would just, you'd do the sums part again, then you would reverse it. So that would be basically this. That's what sums is. So I believe, let's see, one more? No. Okay, well, it's not quite true. Trying to figure out why. Let's think. Why is that not liking it? We have an extra per. Is that it? No. Okay, so sums is this. Sum. Okay. For puzzle input, I think we need more so 2. Let's see, where does this one line up? So I only have 27 seconds, so I'm not going to bother right now. We're just going to get ready for the next one. Yeah, so we'll just leave it like that. Really quickly, I did write a quick util method that reads in the input files, so I just make the input easier. So I've just kind of pre-started this. So we can already read the puzzle input. So here we go. Here's this. This is our puzzle input. It's really easy. I'm going to put it in the test file. I'm going to leave day 2 at day 2 test. Then we'll be able to run our day 2 right there. There's our output. Okay. So we're doing the strategy guide. We're playing rock, paper, scissors, it looks like. Okay. Okay, so we have this guide here. Predicts and recommends the following. In the first round, okay, so the strategy guide says choose rock. Or your total score be if everything goes exactly... Okay, so we don't have to play rock, paper, scissors. We just have to figure out what the score is if the game plays out according to this. So each line is a game. So we're just going to split by each line. So game equals games, puzzle, input, split. And then their move... There's a split lines, which is actually better. So there's ours equals games split on white space. Oh, it's going to bug me that I spelled that wrong. Okay, so we're going to print theirs and ours. And this should just print the same thing. And now, wait, so you get 6 for winning. Oh, but you get different points for each one. Okay, so we're going to build a map here of points. So, okay, so points equals A is, well, really we only need points for us. So Y is rock, Y is paper, so it's worth 2. X is worth 1. And Z is scissors, which is worth 3. So that's the amount of points for what we play. Let's think. And then they play A, B, or C. We get 6 points plus what we play. Ends in a loss with you of a score of 1 plus 3. Okay, so we get 1 plus our win. They don't get any points. Okay, so that's it. We don't have to worry about their points, just whether or not we win. Okay, so basically, we'll just write a quick if statement. This is just going to be dirty. Actually, we could use Python's new match statement, which will actually be pretty cool. So match game. This will actually be cool. We could say we don't need to do this actually at all. So basically we have AX. There's only 6 combinations, so we could technically just hard code them all. So points is 0, and we're just going to do points plus equals A of X. So okay, A is rock for them, X is rock for us, so that's 1 point total, right? A and Y, yeah, X is rock, A is rock, that's a tie, 0 plus 1 point for rock. Okay, so this is going to be points plus equals, it's 2, but we also played paper, so we won. Paper beats paper. So yeah, so 6 plus 2 is going to be 8. Yeah. And then a Z, we are going to lose but get 3 points. So that's 3, right? Yeah, I mean, we could write this in a crazy way where we determine our points and whether or not we win, and we could write out all that logic. It's probably going to help us on part 2, but for now, this case statement is just going to work really well. So, because we only have, yeah, okay, 9. We only have 9 that we need a hard code, so we might as well. Okay, so B and X is the example where we get 1 point. We also get 1 point. Yeah, this one's... Yeah, because we get rock and we lost. That one we got rock and we tied. Is a tie different? Yeah, 3 if the round is a draw. So this one we actually get 4 points. Okay, so this one is a tie plus 2. So we get 5 points. And this one we win plus 3. So that's 9 points. Okay, so this one is they play scissors and we play rock. So they lose, we win. So 6 plus 1. This one is they play scissors, we play paper. So we lose, but we get 2 points. And this one we tie, so that's 3 plus 3. That's 6 points. Okay, so now we're just going to print points. And if this is correct, let's see here, 15. So they say it's a total of 15. Great. So now let's get our input here. And let's try it with the normal input. And let's do this. Let's rerun it. And this is our number. Let's see if that is correct. So here we submit. That's correct. All right, so let's go to part 2. We're probably going to not want to hard code this, but anyways. So X means you need to lose, Y means you need to end the round, and Z means you need to win. Okay. Now you need to figure out what shape to choose so the round ends as indicated. Yeah, see, it's going to, I don't think hard coding is going to help us here. We'll see. First round, they'll choose rock, and you need the round in Y. So you should also, this gives you a score of 1 plus 3. Wait. Okay, so they just mean different things. So we can just do this again. So let's just say this is part 1. Part 1 is here. We'll just split it here. And we'll just copy all this. Points 2, this is part 2. Actually, we could do a find and replace here, and that would be faster, but I'm already done. Okay, so they'll choose A, and you need to round the end in the draw, which is Y. So you'll choose rock. This gives you a score of 1, 3. Okay, so let's just go through all of these. So A still means the same thing, so I'm just going to make this a little easier for me to remember this time. So A equals, because I keep forgetting which one is which. So A is rock, B equals paper, and C equals scissors. Yeah, rock, paper, scissors. I spelled scissors terribly wrong. Okay, so X means, in this case, X means lose. And then Y means draw. So Z means win. Okay. So A to X means we need to lose. In order to lose, if they choose rock, we need to choose... Sorry, I'm still looking these. I should comment more stuff. Okay. So they choose rock. Rock beats scissors. So we need to choose scissors, which is worth 3 points, but we lose. So, okay. So now they choose rock still, but we need to draw. So we also choose rock, which is 1 point plus 3, which is 4. We now choose paper and we win. So that's 9 points. Okay, they choose paper and we need to lose. So we choose rock, which is 1 point. They choose paper, we need to win. No, draw. We need to draw. So we get 3 points plus paper as well, which is 2. So that's 5 points already. In this case, we lose. No, we win. So 6 points plus scissors, which is 3. So that one is, wait, can't both be right. So when they pick rock, we need to pick paper. This one's wrong. Paper is 2 points. So this is 8. X is lose. They picked rock. Yeah, I did this wrong. So if they pick rock and we lose, that means we did, yeah, that's right. Scissors, which is 3. Rock, which is 1 plus 3. Okay, that's right. Okay, so now we skip back to this one. They pick scissors. We need to lose, so we have paper, which is 2 points plus 0. A tie is paper is 2 plus 3, which is 5, and a win is rock. No, wait. They're picking scissors? Yeah, which is rock, which is 1 plus 6, so that's 7. Okay, so now we'll run this again. And that's our second number. Would have been faster if I did not hard code this and had to think of every single scenario. We didn't even get it right. So, all right. So let's make sure we have this right. Let's do it on our test example first. That'll be easier. Because they tell us what the answer should be. It should be 12. And it is 12. So it seems like we're doing it right, but let's double check. So the first round, they'll choose rock, and you need Y. Okay, so we have AY. This gives you a score 1 plus 3, which is 4. Okay, AY is 4. Okay. BX should be 1. And you'll defeat your opponent's scissors with rock. So they're scissors, and we win with rock, which is 7. Oh, because this is win. I forgot this one's win. So I did this one wrong. X is win. So they played scissors, and we played rock, which is 1 point plus 6, which is 7. They play scissors. Scissors is 3 plus 3. This one's 6. And then scissors beats paper, which is 2 plus 0. Okay, so I think I just had that last case wrong. Should still be 12. So I'm doing something wrong. Maybe I adjusted the wrong ones. I think I adjusted the wrong ones. Well, 15. I don't know. Let's go through one more time. So, oh, X is lose. Okay, so I had that right. Now I'm just getting all confused. X is lose. Scissors, I play paper, I get 2 points. Scissors, I play scissors, I get 3 points plus 3 points. Scissors, I play rock, I get 1 point plus 6. Okay, I think that only one might have been the issue. I just had one of them was 1 off, so let's try that one more time. And that one. Okay, that's it. So that's day 2. This is probably not optimal at all, hard coding it. We could try and see what it's like to not hard code it. So basically we just need to program what beats what. And then we don't have to think so much. We just have to know what beats what. But you know it's working. And I mean, with there only being 9 cases, I don't think the hard code is too terrible. So I'm actually kind of happy with this. I'm just gonna kind of leave it. It's not the most ideal, but it definitely gets the job done. So that's it. Thanks. We'll see you tomorrow.